Okay, let's talk about alcohol absorption. I'm going to go back for just a second. Um, you know that alcohol is primarily administered orally. Okay, and so you remember from chapter one that when things are administered orally, the majority of the drug absorption is going to occur through the digestive tract and specifically in the large intestines. Okay, so, what we first want to talk about is what can happen to alcohol if it stays in the stomach for a long time. Okay, now the important thing here to recognize is that we're talking about what can happen to alcohol if it stays in the stomach too long. We're not talking about what can happen to the stomach or what can happen to the body. We're talking about what can happen to alcohol if it stays in the stomach too long. Well, if alcohol stays in the stomach too long, it can be subjected to a significant amount of first pass metabolism. Okay? And if you remember from chapter one, we talked about first pass metabolism being associated with the liver. So you should be saying to yourself, wait a minute, how is it that alcohol staying in the stomach for a long time means that it could be subjected to first pass metabolism? Well, this is a special thing about alcohol. With alcohol, some first pass metabolism can occur in the stomach. Why? Because the enzyme that breaks down or metabolizes alcohol happens to be also found in the stomach. Okay, so that enzyme is called alcohol dehydrogenase, and you'll see how to spell that in your textbook. So if alcohol stays in the stomach too long, it can be subjected to first pass metabolism because the enzyme alcohol dehydrogenase that breaks down alcohol happens to be found in the stomach. Okay, now you'll see here on the slide that it says, what is the end result? So what's the end result of first pass metabolism of alcohol? I'm actually not going to answer that one for you because I want you to think about it. Recall what we talked about in chapter one in terms of what can happen as the result or what the results or consequences of first pass metabolism are. So what I want you to recognize here is that it doesn't matter where the first pass metabolism occurs. Associated with the liver for other drugs, but associated with the stomach for alcohol. Doesn't matter where the first pass metabolism occurs, the consequences are going to be the same. So I'm expecting you to be able to answer that question, what is the end result here? Okay, so let's talk about the things or some of the factors that can actually influence the absorption of alcohol. Okay, so one of the first things that we want to talk about, which can actually affect how long alcohol stays in the stomach, is whether or not there is food present in the stomach. Okay, so if you're familiar with digestive processes, the stomach dumps its contents into the intestines more quickly when it's empty. But when the stomach is full or the stomach has food content in it, then the stomach dumps its contents into the intestines more slowly. Okay, so one of the first things that can affect how quickly the rate at which alcohol is absorbed is whether or not there's food in the stomach. Okay, old folks may say food on your stomach. Okay, but whether or not food is present in the stomach. Okay, the second thing that can influence how quickly alcohol gets absorbed is carbonation. Okay, carbonation can increase the rate of alcohol's absorption. More specifically, champagnes, your sparkling wines, things like that. Those carbonated drinks, the carbonation, those gaseous bubbles, are pushing these smaller alcohol bubbles through those small pores of the membranes more quickly. So carbonation can also influence the rate of alcohol absorption. The third thing that can affect the rate at which alcohol is absorbed is alcohol concentration. Okay, so either the number of drinks that you've had, or if you're drinking something that has a very high alcohol content. Why? If we go back to concepts from chapter one, the concept of, or the process of simple diffusion, things have a tendency to move from areas of high concentration to lower concentration. So the more concentrated the alcohol, the more drinks you've had, which is going to increase the concentration. Things are going to have the alcohol is going to have the tendency to move from areas of high concentration to areas of lower concentration, or relatively even distribution. Okay, so whether there's food present in the stomach, whether the drinks are carbonated, and alcohol concentration, or the number of drinks, are three things that can affect the rate at which alcohol gets absorbed. Okay, now the last thing on this slide is related, but it's different. Here we're not talking about how quickly alcohol gets absorbed, but rather we're talking about how much alcohol is even available for absorption. And so here we're going to talk about the paradoxical effect of antacids. Okay, why do we say paradoxical effects of antacids? Well, if we say something is paradoxical, or something is a paradox, we're saying, that the meaning is not always obvious. Things aren't what they seem. Okay, we know that antacids can increase the pH of the stomach. So if you've got a very acidic stomach, you take antacids to try to reduce the level of acidity, so increase the pH in the stomach. Okay, but the antacids don't affect how much alcohol is available for absorption, because they influence the pH of the stomach. The pH of the stomach has no influence on the absorption of alcohol. Okay, but what the antacids are able to do is, through their effects on the H2, or what we call a histamine type 2 receptor, they're able to reduce the amount of alcohol dehydrogenase in the stomach. Remember that? That's that enzyme in the stomach that breaks down alcohol. So antacids are able to reduce the levels of alcohol dehydrogenase in the stomach. When those antacids reduce the levels of alcohol dehydrogenase in the stomach, they decrease the amount of first pass metabolism of alcohol. So you've got more alcohol that's available for absorption. Okay, so you've got more alcohol that could potentially be absorbed once the stomach dumps its contents into the intestines. Okay, and then in terms of the rate, okay, after that, the same things that influence the rate are still going to be in place. Whether there was food in your stomach, because that's going to determine how quickly the stomach dumps whatever amount of alcohol there is in the stomach, and we know that's going to be more if you've had an antacid. Whether those drinks were carbonated, and the exact concentration. So here with the antacids, it's just important to remember that we're talking about those antacids influencing the amount of alcohol that's available for absorption, because we're talking about lowering the amounts of alcohol dehydrogenase and preventing first pass metabolism of alcohol in the stomach. Okay. Oops, trying to get my slide to advance here. Okay, now, so let's just review briefly. We know that alcohol is primarily taken or administered orally. When things are administered orally, the majority of absorption is going to take place through the digestive tract. On the previous slide, we reviewed some of the things that can affect the rate of absorption, and something that can affect the amount that's available for absorption. Okay, now we're going to talk about, once that alcohol has been absorbed, we're going to talk about its distribution in the body. Okay, so once alcohol has been absorbed, okay, from the digestive tract, it's mostly distributed in body water. Okay, now if you recall in chapter 1, we said that molecules had to be small, neutral, lipid soluble. Well, this is a case where the alcohol molecule is still lipid soluble, but it actually has a fairly high water solubility. So once alcohol has been absorbed from the digestive tract, it's mostly distributed in body water. So here we're going to talk about some things that can influence that distribution of alcohol. So one of the first things that we're going to talk about is body composition, what you're made of. Okay, So a lot of people have assumptions that it's always a matter of big and small, but what matters is what the big is made of and what the small is made of. So you may already know that oil and water don't mix. So in our bodies, it's not really oil, but it's fat. Fat and water don't mix. So for an individual, the more body fat you have, the less lean muscle you have, the less body water you have. Okay, do you see how that works? The less, the more body fat that you have, that means the less lean muscle that you have, and you have less body water. Okay, the more lean muscle you have, the less fat you have, the more body water you have. Okay, so we know that our bodies are composed primarily of water, but that amount of water can differ based on whether or not we've got lots of lean muscle or if we've got lots of fat. Okay, so the body composition, because remember, after the alcohol has been absorbed from the digestive tract, it's going to mostly be distributed in body water. Okay, our second thing here that can influence the distribution of alcohol in the body is sex. Okay, so males and females generally differ in the amounts of body fat because evolutionarily speaking, females their bodies are made to produce offspring. Females, the average female has more body fat than a male. Okay, and so you could have a male and female that are of equal weights, but the female may have more body fat, which means she has less lean muscle, less body water. So if they drink the equivalent amounts of alcohol, you could potentially have a female that has a higher blood alcohol content because she has less body water in which to distribute the alcohol that she's drank. Okay, so sex is our second thing. The other thing is age. Okay, as we get older, okay, we tend to acquire more body fat. Okay, and again, it's a matter of what you're made of. You could have an individual who has maintained a good range in terms of their body weight as they've gotten older, but most individuals tend to lose the lean muscle mass and have more body fat as we get older. The other thing that's interesting is that you'll see some people who still wear the same size clothing that they did when they were younger, but what that body is made of is very different. It's no longer the very lean muscular structure, tends to be a bit more body fat involved there. Okay, and so all those things are related to body composition. And the interesting thing is that as we age, the differences between males and females are narrowed. Okay, because the males, just like the females, are acquiring more body fat as they get older. So you still see gender differences, but the gap in terms of body composition are potentially closed. And I'll mention here that when we talk about things like this, we're talking about the average individual. We are not talking about our high performance athletes who have essentially no body fat. We're talking about the average Joe Smo or the average Jane Doe that's walking around. Okay? This last thing here on the slide is just reminding us that what the amount of alcohol in the blood is going to be reflected in the lungs. Remember when we talked about how you can measure blood alcohol content, we talked about the breathalyzer. We know that alcohol vaporizes at a known rate. So the air that you expire, that's going to reflect the amount or the concentration of alcohol in the bloodstream, okay, when we talk about alcohol distribution. So that's just a reminder there, okay? Now, let's talk a little bit about the metabolism of alcohol. At the top of the chapter, when we looked at that curve for your blood alcohol levels after a single drink, we talked about zero order kinetics. Remember, this means that alcohol is metabolized and excreted at a constant rate. Okay? Remember, my constant rate is my constant rate. Your constant rate is your constant rate. The constant rate of a social drinker is going to be very different than the constant rate of an alcoholic. Remember, we used that analogy of three cars that are traveling on the interstate. They've all got the the cruise control set, so they're all traveling constant speeds or constant rates, but one may be going 75, one has their speed control at 65, one has the speed control at 55. Zero order kinetics. Alcohol is metabolized and excreted at a constant rate. Okay? And then here's our friend alcohol dehydrogenase again. Remember, that's the enzyme that's responsible for the metabolism of alcohol. And we actually refer to alcohol dehydrogenase as the rate limiting enzyme for alcohol metabolism. Why do we call it the rate limiting enzyme for alcohol metabolism? Because the amount of alcohol dehydrogenase that an individual produces determines the rate, determines their constant rate, determines that constant rate at which the alcohol is metabolized and excreted. Okay, so again, alcohol dehydrogenase, the rate limiting enzyme for alcohol metabolism, because the amount of alcohol dehydrogenase that an individual has is going to determine the rate at which the alcohol is metabolized and excreted. The level of alcohol dehydrogenase is going to determine that constant rate for any individual. Okay, and then the influence of drinking experience. As an individual continues to drink, okay, the liver is going to produce more enzymes. Okay, so remember in chapter 3 we talked about metabolic tolerance. Okay, an increase in the body's ability to metabolize a drug because of enzyme induction or the increased production of enzymes. So with the continued drinking experiences, the individual's body will produce more enzymes, which will then break down alcohol more quickly because you've got more enzymes. Now let me mention something quickly here that I neglected to mention, because on the previous slides we talked about the fact that alcohol dehydrogenase is found in the stomach. Okay, but the liver also produces alcohol dehydrogenase. Okay, so remember, if the alcohol stays in the stomach for a long time, then it can be subjected to some first pass metabolism there because alcohol dehydrogenase is found in the stomach. But let's imagine that the person drinks on an empty stomach. Okay, then you're not going to have any significant first pass metabolism happening in the stomach. What's going to happen then is that once that alcohol then gets absorbed from the intestines, enters the bloodstream, the liver would then secrete alcohol dehydrogenase that would break down the alcohol. Okay, so I just wanted to be clear that you've got the alcohol dehydrogenase in two places. Okay, so you've got the alcohol dehydrogenase that's found in the stomach, but the liver also produces alcohol dehydrogenase. Excuse me. Okay, there is another enzyme system called the microsomal ethanol oxidizing system, which helps out with the metabolism of alcohol. Okay, I think your textbook says it normally handles anywhere between 5 to 10% of the alcohol metabolism. This system is usually most active if the individual has very high blood alcohol concentrations, and so it can really speed up the metabolism of alcohol. And it's thought that the activation of this system is what's responsible for the ability of alcoholics to drink lots and lots of alcohol, because this system is helping to metabolize that alcohol. Rates can be doubled or tripled. Okay, one of the issues with continued drinking experience, with drinking high levels of alcohol and activating this MEOS system, is that this system has other stuff that it does. It's a system that is also responsible for metabolizing barbiturates. Now, that's a class of drugs that we'll talk about a little bit later on, but those drugs are sedative hypnotics. Okay, so the issue there is that if you had a person with a sleep disorder, etc., but has this alcohol history, because this MEOS system has been continuously activated due to that person's drinking, then the individual who is prescribed barbiturates, those barbiturates, excuse me, would be much less effective because this MEOS system, the enzymes of the MEOS systems would be present in high levels because of the drinking experience. And those enzymes aren't going to discriminate and say, oh, it's a barbiturate this time and not alcohol. You're just going to have high levels of those enzymes, which are going to break down the barbiturates that the individual is taking for the sleep disorder. Okay, so those drugs would be less effective in someone with the alcohol history. And we'll bring that up again when we talk about the barbiturates. Okay. Uh, let's talk a little bit about the neuropharmacology of alcohol. I'm not going to say a whole lot. Oops, sorry about that. Sometimes we refer to alcohol as a dirty drug. Why do we call it a dirty drug? Not because of anything related to cleanliness necessarily, but alcohol is a drug that affects nearly every neurotransmitter system in the brain. So, the very simplistic way that I often talk about this in terms of how and where alcohol works in the brain is that alcohol works in many places, many different areas of the brain. Because remember, I said it affects just about every neurotransmitter system in the brain. So it works in many different areas of the brain, and it's going to do so by either directly or indirectly affecting the ion channels that are associated with the various neurotransmitter systems. Okay, so alcohol works in the brain, in many different areas and in primarily two ways: by directly or indirectly affecting the ion channels that are associated with specific neurotransmitters. Now, your textbook is going to mention in this chapter, two neurotransmitters in particular, because those are two neurotransmitters with which we associate the majority of alcohol's effects. So we're going to talk about GABA, gamma-aminobutyric acid. That's the major inhibitory neurotransmitter in the brain. I like to call it the policeman of the brain because it's a major inhibitory neurotransmitter in the brain. It's a neuromodulator. It keeps other neurotransmitter systems from becoming overly excited. So I like to say it maintains the peace. That's why I call it the policeman of the brain. And I think later we'll talk a little bit about the GABA A receptors because those are the ones that, in terms of alcohol, some of its effects, which we'll talk about in just a few slides, and the effects of barbiturates are associated with, because there's another type of GABA receptor that does have some excitatory effects. Okay, but GABA again is the major inhibitory neurotransmitter of the brain. Okay, and then your textbook will also talk about glutamate. Okay, and glutamate is one of the major excitatory neurotransmitters in the brain. So your textbook will also talk about the effects of alcohol on glutamate. For our purposes, okay, we want to recognize that alcohol works in many, many different areas of the brain. Okay, it works on a number of neurotransmitter systems. We know that its effects on GABA, which is inhibitory, its effects on glutamate, which is excitatory, are very important to the effects that we know are associated with alcohol use. And alcohol produces its effects in the brain by either directly or indirectly influencing the ion channels that are associated with the neurotransmitter systems. Okay, so let's briefly talk about some of alcohol's effects. Alcohol has what we call biphasic effects, phasic phases, two phases of effects which are associated with excitatory and sedative effects. Okay, so the first thing, or the first part of these biphasic effects, is that at low doses and when blood alcohol levels are rising, alcohol has excitatory or stimulatory effects. Okay, at low doses and when blood alcohol levels are rising, alcohol has excitatory or stimulatory effects. Okay, so this is when individuals have just begun drinking, the alcohol is being absorbed in the system, and this is when people report that buzz, that euphoria, excuse me. At low doses and when blood alcohol levels are rising, alcohol has excitatory or stimulatory effects. Okay, then the second part of this biphasic of these biphasic effects is that at high doses and when blood alcohol levels are falling, alcohol has sedative effects. Okay? At high doses and when blood alcohol levels are falling, alcohol has sedative effects. Okay? Now, the important thing here is to recognize that when we say blood alcohol levels are falling, that doesn't mean they're low. If we think back to that curve that we use at the beginning of the chapter to show blood alcohol levels after a single drink, okay, that when we're talking about blood alcohol levels are falling. We're talking about that portion of the curve C, that portion of the curve. So you may want to flip back or flip in your textbook. Look at that part of the curve where it says excretion is starting to lower the levels of alcohol. That part of the curve is higher than the rising. So don't misinterpret that phrase when blood alcohol levels are falling to mean that the levels are low. That's when individuals experience sedative effects. They start feeling a little lethargic, a little sleepy, maybe slurring their words, the eyes are drooping. Okay? So again, just briefly, at low doses and when blood alcohol levels are rising, alcohol has excitatory or stimulatory effects. Okay? At high doses and when blood alcohol levels are falling, alcohol has sedative effects. Okay? And you probably need a little break, so I'll stop here and then pick up the next section.